Assalamu alaikum students. Now today we will talk about the equations of motion. What are the equations of motion? Basically, these are the set of three equations which relate some of the quantities which describe the motion of an object. So, on the basis of whatever we have studied so far, what did you observe? What are the quantities that you need to describe the motion of object? Well, the quantities are displacement, velocity, initial velocity, final velocity, acceleration, time taken. These are some of the quantities which all together can describe the motion of an object. Whether the object is at rest or in motion, or if speed is increasing or if speed is constant. So, all such details can be obtained with the help of one or more of these quantities. So, equations of motion are set of three equations which establish relationship between displacement, which is denoted by S, time taken denoted by T, initial velocity denoted by U, final velocity that's represented by V, acceleration that is represented by A. So these are some of the quantities which are linked to each other by these set of equations. Now, what are these equations? They are also known as kinematic equations of motion. The word kinematic means something in motion. So these equations are, the first one is V is equal to U plus AT. S is equal to UT plus 1 half of AT square, and V square is equal to U square plus 2 times AS. These are the general forms of these equations. Say suppose if there is a scenario where you have a negative acceleration, then this A becomes minus A. So equation will become V is equivalent to U minus AT. S is equivalent to UT plus UT minus 1 half of AT square. V square is equivalent to U square minus 2 times AS. So first of all, we will look at the derivations of these equations. So we will derive the first equation, V is equivalent to U plus AT, by graphically. So here I am having a graph, and I have taken the velocity time graph. So we have taken generalized velocity type graph, and you can see here on x-axis represents the time and y-axis represents the velocity. This is a generalized velocity time graph. Now, as you can see here, as time is increasing, velocity is increasing from this point. So it means this point is the initial velocity. This point corresponds to the represents initial velocity. It means this is our initial velocity U, and this point because velocity is increasing till this point, so this point corresponds to final velocity. It means this is our final velocity. Okay, and this is a time axis, so this represents time. Now if we join this line here and here, so let's suppose we are, say this point is O, this point is A, this is here B, this is here C, and this point is here D. So let's derive the first equation of motion. V is equivalent to U plus AT from this graph. So as you know, in velocity time graph, slope of the line, it means slope of AB, represents acceleration. So this slope of this line AB represents acceleration. So we'll write slope of AB gives acceleration, right? Now from slope, what do we mean by from slope? Okay, so as you can see here, from this point to this point, we have got a right angle triangle here, and to find the slope of this line, we need to divide perpendicular by base in this right angle triangle. It means BC divided by AC. So slope will be BC divided by AC and acceleration is small a. So BC. What is BC here? Now you can see from O to this point, it means from O to, if you say from to point B, from this point to this, as this line is parallel to this line, so you can say O to this point or you can say DB, and it's represented by final velocity. It means from D to B we are having final velocity, and from O to A we are having initial velocity. It means this represents initial velocity. So what is our BC? You can see here BC would be nothing but BD minus CD. So I can write here, instead of BC I can write BD minus CD divided by AC is equivalent to A. Now BD, what is our BD? That is V, final velocity. CD, that is our initial velocity. U, AC. AC represents, AC and OD is equal, and both of these represents time. So T. Now see here, T will go here and it will be V minus U is equivalent to AT. Now you can see here we need final velocity V. So I will keep it like as it is. U must be transferred here. So when negative U goes here, it will be positive and you will get V is equivalent to U plus AT. This is our first equation of motion. Now second equation of motion, that is S is equivalent to ut plus 1/2 of at square. So look at this velocity time graph. We need actually S, displacement. So you remember, as I told you in previous lecture, that area under the velocity time curve gives you displacement, and here area under this curve is this portion, this area. When I say area under velocity time curve, it means area under this curve. So I will get this area. So here you can say it means area of this curve means area of triangle and area of rectangle. Okay. So to get the displacement, area of velocity time curve is equivalent to area triangle. Which triangle? Triangle ACB plus area rectangle OACD. And area of velocity time curve gives us displacement. Then area of triangle, that's base into height, and here 1/2 of base into height. So 1/2, and base is AC and height is BC. Plus area of rectangle, that's length into breadth, so OD into CD. S as it is 1/2. AC, what's for AC? That is time. And BC, that is, you can see here BC is V minus U. So I can write V minus U here. Then OD, what's our OD? Time again. And CD, you can see here CD represents U. So S 1/2 into T. Now see, V minus U, you can see here V minus U from this equation, first equation, V minus U is equal to AT. So instead of V minus U, I can write here AT by using equation first. Okay. So then U into T, that is UT. S as it is 1/2. T into T is T square, and AT square plus UT. You can write it like this also. First you will write this UT, then plus 1/2 of AT square, and this is your second equation of motion. Okay. Now we need to derive third equation of motion, that's V square is equal to U square plus 2 times AS. Again look at the graph. Again we will take the area under this curve, and at this moment we will take the whole area, that is it will form a figure of trapezium. It means area of trapezium. So area under velocity time curve, and that is area of trapezium. Area of trapezium OABD. Again, area under velocity time curve is nothing but displacement. And what is area of trapezium? That's 1/2 of height, sum of parallel sides. So what is the height in this trapezium? That is this OD, or you can say AC. So OD, 1/2 of OD. And what are the parallel sides? OA and DB. So 1/2 of height, that is OD, and sum of parallel sides, that is OA plus DB. Now what's OD? That is time. And what's OA? OA is our U, and what's dV? That is V, final velocity. So U plus V. Now S as it is 1/2. Now instead of T, we can write V minus U divided by A. See here. From this equation, you need to derive value of T. So you will get T is equivalent to V minus U divided by A. So substitute this value of T here. So V minus U divided by A. You can write it V plus U. This is A minus B, A plus B, identity. So it means this is equal to A square minus B square. It means B square minus U square. So 2A will go here. It's 2A times S, that's V square minus U square. Now if U square gets transferred here, so it would be U square plus 2AS is equivalent to V square. You can write it also like this: V square is equivalent to U square plus 2 times AS. This is the derivation for the third equation of motion. Thank you.